And we made it. Good morning, good time of day, whenever, wherever it is. I hope you are having a lovely time. Because for me, I'm like, I hope you're having a lovely start of your day, but it might not be the start of your day. It might be just a day. That is happening. Alright. Are we good on things? Mostly. Settings are settings. And I left things just like I just left things yesterday, so I can jump right back into it. I don't think I have any house cleaning things, so is that what it's called? Is it I just forgot. Anyway, hi Aaron on the YouTube side, what is up? And yes, let's do this. I'm like, hi Botrix, the bot. Okay, so today is, oh wow, it's the 22nd of November already. Wow. Time just goes. Up next, what does up next mean? All right, so blazing, nice. So today's plan is just doing this final section of the unit thing and then doing the unit test. Will I be able to do that in like two hours? I hope so. I don't, we'll see. Let's the way I see it is video, frequently asked questions. So cool. The only part is this part that is solving situation, and then obviously the unit test is going to be probably 10. I think there are 10 questions. Yeah. And I don't know if anyone noticed when I was starting, I was in the starting soon thingy. I increased the waiting time by 2 minutes because I was feeding the cats, and I wasn't sure if I'll be back in the time limit I set for myself. So that was not a glitch. That was me increasing the time. Alrighty. A problem about a toy factory. Huh? Do I have a notification? Oh, we unlocked some. Ooh. Oh, these are some fancy faces. So many fancy faces. Why is it called Benjamin Franklin? Okay. So in these problem sets, I would like to, oh, here's a, way rude. I thought it's video, but no, that's a practice point. So I think if I see the problem as being, oh, hi Drew, what's up? Chillin'? Cute. Like, if the problem seems easy, I'll try to solve it-ish and then just skip the video in a way. But if it's not, then I'll wait for it. Like right now I'm looking at this, and it may be a 2 problem video, it might not be a 1 problem video, but let's see. It says, I should play it. Let's play it and see.
We're told a factory makes toys that are sold for $10 a piece. The factory has 40 workers, and they each produce 25 toys a day. The factory is open 5 days a week. What is the total value of toys the factory produces in a day?
Okay, like to me, I feel like this can be done with mental math. I could be wrong. Let's just try. Total value, so the output we want is money, the factory produces in a day. And how many toys are made in a day? Well, we have 40 workers that create 25 toys a day. Meaning 40 times 25 is the number of toys, and then we again multiply that by the money, which is $10. What is 40 times 25? 4 25s is 1,000. Oh. And then, wait, what? 4 25s is 100. With the 0 is 1,000, right? Did I get that right? Let me try again. 5 times 4 0. It is 1,000. Wow, my mental math is mentaling and mathing. And then 1,000 times 10 is 10. 100. 10,000. So that is my final answer for a day. Let's skip to the end and see if we get there. 10,000. Yeah.
And then the units we're left with is dollars.
Yeah. But it looks like he's like converting units. I wouldn't do that. Toys per worker. Times workers. Workers go away. Toys remain. Times dollars per toy. Ooh, I would not do that. You are just making it difficult for yourself. What else? Let's see if we can solve this one.
We're told that
Ricky is going on a road trip that is 100 kilometers long. His average speed is 70 kilometers per hour. Okay, so now we have an actual unit that maybe I should be careful about. 70 km per h. At that speed, he can drive 5 kilometers every liter of fuel. Okay, fine. I guess personally I would do these calculations to see how many liters of gas I would need. Fuel, yeah. Fuel costs 0.60 liters dollars per liter. What is the cost of fuel for the trip? That is so long. I don't want to do this. Why am I doing this to myself? Okay. Average speed is 70 kilometers per hour, right? Okay. And he drives 5 kilometers per fuel, right? So how do we get these to be similar? I would. Both kilometers are at the top. Fuel is... I don't like this. Do we have any other? Fuel is 0.60 dollars per liter. I obviously need to do some conversions here. Where do we start? And he can drive 5 kilometers. Okay, now we have something that is sort of useful. Oh, this part is liter. Okay, good. So, how would my brain without support would do this? Without, like, how would I understand this personally? 5 kilometers per liter of fuel. How many kilometers is the whole trip? Or per hour. So what I would do is 70, like I would say we have 100, and I would divide it by the 70 kilometers per hour to get how much 5 kilometers are in that, right? Do we need speed? No, we don't need speed, do we? I'm gonna pause on the speed and just say it's 100 kilometers long, and how many 5 kilometers at that speed? Okay, we have a speed, good for us. 5 kilometers per liter. So how many 5 kilometers are in 100 kilometer long road trip? When we get that, even though these two are these two similar? Not fully, but let me just get there with my brain. 20 20 would be the correct answer, right? So now this is 20. So we have 100 kilometer per hour divided by let's just say times 1/5 kilometer per liter. So in my humble opinion, kilometer and kilometer go away. We have hours per liter remaining. Does that make sense? No. That doesn't make sense. Liters are per hour would make more sense to me. Because it's like, yeah. So like, we would be using 20 liters. Well, just liters, honestly. That would just be liters for me. And then we times this, the 0.6 of the money, and I would get what is 0.6 of 20? 0.5 is more clear, but not 0.6 in my mind. 20, that is 12, okay. And like for me the cost would be 12 what? Not $12, I doubt that. Let's see. So I'm gonna watch the video and see how his brain works, because mine just mine struggled, as you can tell. Let's play.
Ricky is going on a road trip that is 100 kilometers long. His average speed is 70 kilometers per hour. At that speed, he can drive 5 kilometers for every liter of fuel that he uses. Fuel costs 60 or $0.6 per liter, so the equivalent of 60 cents per liter, but they wrote it as $0.6 per liter. What is the cost of fuel for the trip?
If they had written cents, I would not be able to convert it to dollars, so I'm thankful for that part. Let's zoom in just a bit.
Pause the video and see if you can figure
I
that
did.
It's 100 kilometers long. They tell us that the average speed is 70 kilometers per hour. So 70 kilometers per hour. They tell us that at that speed, we can drive, or he can drive 5 kilometers for every liter of fuel that he uses. So 5 kilometers per liter. And then they tell us that fuel costs $0.60 per liter. So then this last piece of information right over here is that fuel costs $0.60 per liter. Normally we would see that written as 60 cents per liter, but let's just go with it this way. So
okay, I also wrote most of these down. I just didn't get anywhere with it. Like this liter with this liter would work. This kilometer with this kilometer would work. But personally, I don't think the 70 is useful. Let's see if he uses it.
It's going to be useful for the total cost of the fuel for the trip. Well, we need to figure out how much fuel we're going to use and then multiply that times the cost of the fuel. So how much fuel are we going to be using? Let's see, we're going 100 kilometers, that's the total distance. And then this tells us essentially how many liters we're going to have to use over those 100 kilometers. Now you might say, how exactly does that work? Well, if I'm going 5 kilometers per liter, if I were to take the reciprocal of this information, I would get 1/5 of a liter per kilometer. That's how much fuel I use per kilometer. 1/5.
Hey, I did that. Yes, okay, so I should have flipped the thingy. I should have.
1/5 of a liter. And so why is that useful? Well, if I take 100 kilometers, and if I were to multiply it times 1/5 of a liter per kilometer, this is going to tell you that over the course of this trip, I am going to use 100 times 1/5 liters. Or this is going to tell us that over the course of the trip, we are going to use 20 liters. And then if we were to multiply that times the cost of fuel per liter, well, then we know how much the cost of our trip is. So let's do that. And then let's multiply this times.
Hi, Asher. So, how's the growth of the tree? How's the growth of the tree? I think we are driving to see where that tree is because we're going on a road trip. But I just realized in my calculations, I said 100 kilometers per hour, and that was wrong. There was no hour. So it is correct that the answer of the 20 is liters and not liters per hour. That I got wrong. So is the answer really $12?
$0.60 per liter, which is the same thing as multiplying this times $0.60 per liter. The liters cancel out, so it's good that our units work out. We're left with just dollars here. So 20 times 0.60 is going to get us to 12. So we are left with $12. And we're done. That's the cost of our trip. And I know what you're thinking. Wait, we didn't use the information right over here that he's traveling an average speed of 70 kilometers per hour. It's true, we did not use that in our calculation, although it was kind of useful because we had to know what his fuel efficiency is at that speed. So they're saying they're traveling at 70 kilometers per hour, and then at that speed, we get this fuel efficiency. Now, they could have just told us. They didn't even have to tell us this. They could have just told us at whatever speed he's going, his fuel efficiency is this, and we still would have been able to figure out the total cost of the fuel for the trip.
Like, how can I be so wrong and so right at the same time? I'm proud of myself for getting the answer, but God, did I struggle. Let's go. Let's see if it includes any tree growth. So Astrid, I love that name. It has to do with astro stuff, right? Is in charge of building a new fleet of ships. What? What? Who? What? Astrid, are you? Ooh, that's scary. Each ship requires 40 tons of wood and accommodates 300 sailors. She receives a delivery of 4 tons of wood each day. Cool. So, all right. The deliveries can continue for 100 days. At most. How many ships are we making? And afterwards the weather is too bad to allow them. Overall, she wants to build enough ships to accommodate 2,100 sailors. Each ship, Schrodinger's. Yes. So, my answers are very Schrodinger's, yeah. Each ship accommodates 300 sailors. We want to be able to build enough ships to accommodate 2,100 sailors. So first thing I would do, 7. I was like, I need to divide this by this. Hello? What just happened? It's been a while since I've had a serious internet cut scare. Did I just get an internet cut? RIP indeed. Am I alive, dead? I'm live. Okay, I'm live. I'm back. No, did my Schrodinger's answer is that why? Whoa, it's been a while. How? I hope. I have no idea how that happened. Sound only? No. No, I should be back, right? Am I not fully back? I see myself in my monitoring situations, back on both YouTube and Twitch, hopefully. Can you not see my face? It's back. It's fully back. Alhamdulillah. Honestly, I have no idea what happened, because now my internet is really good. I have no idea what happened. Hello, I'm back. Where was I? Did I say we have 2100 sailors and 300 sailors here? It's just 21 divided by 3, so that's 7. We need to build 7 ships. And then, I'm so scared of the internet right now, like, monitoring. So 7 ships, and then each ship requires 40 tons of wood. Where did that 70 come from? So we just say 40 times 7, and that's the number. Wow. Something is happening. Wow. Something is happening. Why though? Again. Should I go and check the internet before it messes with me? Because now it's like normal. Back very normal. Okay. So it's now back again. But if I get another scare, I'm going to go to the BRB screen and try to check what is the problem. Now it's actually really good, so yeesh. Anyway, it's 40 times 7, and that should be 28.0. Let's check the answer. Back to audio only. Refresh, please. if that. Oh, hey, that was the answer. Is it Twitch being not? Maybe a refresh would work. Let me do that on my side as well. Looks reasonable on my side. Again, if I get another scare, I will get up physically and check the internet, because I shouldn't be getting those issues. I'm going to go for the next question and just Twitch is twitching. That's a funny one. Glitching and twitching. I think when video pauses, like it's trying its best to continue, which is nice. I will say YouTube is doing great in the not dying on me, because it used to be like the most unstable, but then it's pretty stable with cuts, like actual cuts. All right, I will be like, it's in the corner of my eyes. I will see it if it's gone. The house Trevor's family lives in has 6 people, including Trevor, and 3 bathrooms. Ooh, that's a difficult calculation. I mean, it's actually a lot of bathrooms. I'm just saying. In the past month, each person showered, who cares, for an average of 480 minutes and used an average of 72. Interesting. So we can calculate how much money each person uses based on how long their showers are. Interesting. Over the entire month, water costs $0.2 per liter. How much money did Trevor's family spend in total on shower water in the past month? So, do we know per day? No, we have the entire month, which is good. So we have 6 people. 6 people. We don't care about the number of bathrooms. That's not relevant. Each person showers an average of 480 minutes. So that's the number of minutes. That's also not relevant the way I see it. 72 liters of shower water. That's it. You just say 72 times 0.2. You get you get the money for one person, and then you say times 6, and you get it for the whole family. That this is not relevant. Yeah, we just get irrelevant information. So we do, oopsies, you should be there. So we get 72. Oh, wait, 72. And then times, I guess if I say 72 times 6, we get the water usage for 6 people. And then we say times 0.2. And now we get it for the whole family, $86.4. That's pretty good. $86.4. Let's check. Ready? Hey! Alright. Linux, that's a cool name, owns a big apple orchard. She ships her apples to various markets using fleet of trucks. Cool. Every week each truck goes on 3 trips, and each trip Linux gets $300 per week. Oh, 3 times 3. Okay, 900. On a single trip, a truck delivers 50 packs, and each pack contains 12 kilograms of apples. Overall, she sells $4,500 of apples in a week. The question is, how many trucks are in the fleet? How do I get that information out of this? Let's try again. So, so I think I can get the information out of the money, not the how many packs, because we say each week we get 3 trips, and each trip costs $300, and she sells $4,500 per week. What we can do is get the 300 out of here, so the dollar goes away and we get the week. That is my personal opinion. And again, this is per trip, and this is the full week. So it's either I divide it by 3 and I get, what do I get if I divide by 3? I get cost per, no, anywho, that's my that's my solution. We have $300 per trip, and then we have you. So if I say, well, I guess I have to divide this by that big number by small number. How many 3s are in 45? I cannot have an in total number of trucks. That does not make sense. And fleet, dollars worth of apples. On a single trip, a truck delivers 50 packs and each pack contains, that cannot be relevant. I don't see the relevancy in that one. But if I divide the calculator, you come here. 4, internet is still interneting, goodies. 4, where's the 4? Here it is, 4,500. Divided by 300. 3 trips. 15. Oh, what? 45 is divisible by 3. Huh. Is that the number of trucks? That's so many trucks. I feel like, that's too many trucks. I mean, good for her. I'm gonna check. I could be wrong. I was wrong. Okay, do I need to divide by 3? Yeah, because it's number of trips. Okay, so the answer is 5. Yeah, I knew it. Alrighty. Next question. Ooh, David is making rice for his guests. That is awesome. David is nice. Interesting. Okay, just checking stuff. Based on a recipe that requires rice water. Isn't rice water? It's just rice cooked in water, and a special blend of spice. I feel like I know what rice he's making. Where the rice to spice ratio is 15:1. As a person who is very particular about using like measurements when attempting to create something that is considered food, I appreciate this, but I find it to be very taste-based. Like, even as I am very serious about using measurements, I still believe when it comes to spices, it's taste-based. Like, there are more important things that require a lot of measurements, but I don't think that's the case for spices. Anyway, so that 15:1 is just weird. He currently has 40 grams of the spice blend. Nice. And he can go buy more if necessary. He wants to make 10 servings, where each serving has 45 grams of rice. Oh god, overall, the money is not relevant though. How many servings can David make with the current amount of spice he has? So, he has 40 grams of spice, and oh, the money is relevant. Rude. Is it though? 10 servings, where each serving is 45 grams of rice. Based on the spice? Do you have a I guess we have the high ceiling. The ceiling is 40 grams. So 40 grams of spice and 75 grams of rice. The point is here, like, this 40 grams is not necessary at this point because 10. So times 10, first of all, just to get the full food. So we have, is that 7 kilos and a half rice? And then the 15:1 being rice to spice is how many 15s are in 75, then we get the 1. If we get this to be 15, we get this to be 1, and then and then we do something with 40. Just let me think about this. So how many 75 divided by 15? So for that one, 50. Huh? Am I going in the wrong direction? Because here's the thing. The 15 is the rice. And if the rice... I need to get the rice to be 15. And I don't think the division is... I don't think it's the division. Like, for me, it's conversion between numbers. When I have a grade in a number that's not 100, and then I want to see how much I got for 100, like, for example, the TOEFL, is it TOEFL exam, you get like a number out of 120, but like, that doesn't make sense to me. I want to convert it into 100. Then I feel like this is the same. So like, I am converting 7 let's just convert 75 to 15 for the time being, and then we can then get that 1, because here the answer is 5. So do I say so now 5 times 1 is 5, so we have a ratio of 15 to 1 or 75 to 5. So that's per food, per one food. And if we're doing 10 servings, so the answer is 50. Oh, darn it. Per serving though, right? How many servings can he do? Ah, all right. He cannot do 10. He can do, because like 50 is not viable if we times this by 10. What is viable? 9 is not viable. 8, in my opinion, 8 is viable, because even 9 would be 45. God, I don't know how I got there, but I'm just gonna write 8 and wish for the best. That was, did I just press back? Please don't. They changed the question. They changed the question. At least I feel like I remember this. How long can she drive? They changed the question on me. God, this is difficult. Anyway, it's okay. We can do this. Rosalind is driving to visit her family, who lives 150 kilometers away. Her average speed is 60 kilometers per hour. Car tank has 20 liters of fuel, and fuel efficiency is 6 kilometers per liter, and the cost is this much. So, how long can she drive before the fuel runs out? So the dollar, not relevant, but it's 150 kilometers away, so that's relevant, and we have 20 liters of fuel, and efficiency is 6 kilometers per liter. I feel like that's all the information we should need, because okay, internet is still there. I thought I lost the internet. Nice, we're back. I mean, we have been back for a while. So I don't think the 60 kilometers per hour is relevant, right? How long? It is very relevant because we need to know the time. So first we need to know 6 kilometers per liter. So we want to know how much we can drive with 20 liters of fuel. We just say 6 kilometers per liter times 20 liters. We get 120. This goes away, kilometer. So that's first how far we can go, but how long is, now we have 120 kilometers, and we have this we have this kilometer per hour, but we want the hour to exist, so we just say 1 hour. Oh, this is hour. Z hour, and the 60 kilometers, so that this goes away, this goes away, this goes away, this goes away. Are you telling me 12 divided by 6? Wait, did I just go to 20? That hold up. No, 2 hours, not 20, because 2 and 1, so 2 times 1, 2 hours. My answer is 2 hours. Whether that's correct or not, that's, you know what, who knows. 2 hours. Please be correct. Thank you. Bonus question. What? Cool. Nice. Something about uploading videos on a channel. Degogo uploads 3 videos on his channel every month. Wow, you're busy. Each video averages 15 minutes in length and gets an average of 150 new views. Awesome. The average ratio of likes to views is 1 to 5. Huh. Isn't it normally 1 to 10? Degogo wants to reach 9 million views on the channel. So assuming these rates continue, I mean, normally rates grow, but let's say, okay, how many months does Degogo need to upload videos to get to 9 million views? So we have 3 videos a month. Th. Okay. And each video gets 150,111 views. So if I times these two, I get number of views a month, and we want to know how many months. So 3 times 15 is 215 is 30. Another one is 45. 4, 5, 1, 2, 3. And then I need to divide that like 9 million. 1, 2, 3. 1, 2, 3 divided by this number. So all of these zeros go away. 900. How many 45s are in 900? How many 45s are in 900? 900 divided by 45. 20. 20 months. Is that correct? Does that sound correct? Let's see. That sounds correct to me. Let's go. Hey! I deserve the music because I went a level up, by the way. That's what the music was for. Yeah, good job me. Whew. Now something tells me I don't have the energy for the unit quiz, but let's just try. Because I don't know why the questions are so long.
I just received this drug calculation problem from a nursing student, and I think it's essential that the nursing students out there are able to do this, just in case I'm the patient receiving the drug.
Okay.
So let's do it. And I think it's an interesting unit conversion problem for pretty much anyone who wants practice with unit conversion. So the question is that we have a doctor.
Okay.
The doctor orders drug X. Drug X.
Are we going to be converting something about like how many patients we get in a month and how much of a drug we should order based on their consumption?
And this is the dosage that the doctor's requesting. They're saying 5 milligrams of our drug
Per patient?
pound of patient weight.
Oh.
Or I'll just write per pound of patient weight every 12 hours. This is what
That's cool. Per patient weight. I did not expect that.
we're supposed to do. But our supply of the drug, let me write here, our supply in green. It isn't just, it's not just nuggets in milligrams. It's a solution. There's a certain amount of grams per every milliliter that we have of the solution. It's dissolved in probably some water. So this is our supply of drug X. Drug X. We have 0.9. I'll write a 0 in front. My wife, who is a doctor, says it's essential to write the 0 in front of the decimal. We have 0.9 grams per milliliter. Milliliter of solution. So if I were to take 1 milliliter out of my solution and give it to someone, I'm essentially giving them 0.9 grams of this drug. And then the final piece of information we're given, is that the patient, they weigh, and maybe we should say they mass, because kilograms is mass, but we get the idea. The patient is 72.7 kilograms. 72.7 kilograms. So there's a couple of interesting things here. We have to figure out the dosage in terms of milliliters. We have to, actually, I didn't even tell you the question. We have to say, the question is, how many milliliters of solution do we have to give to the parent per dose? To the
Patient, not parent. I would actually round up this. Is that bad?
patient per dose. So milliliters of solution per dose. That's our question. And there's a couple of things. We have to go from milligrams to grams, and then convert that to milliliters. And then they tell us per pound, but then they gave us the patient's
Oh
weight or
my
their
God.
mass in kilograms. We have to do.
I did not realize this is pounds. That's just mean. Hold up. Gram to milligram. And then milliliter, so the final answer has to come from here. But every 12 hours, does the time matter?
Some conversion there. So I definitely can appreciate how this can be a little daunting and maybe confusing at times. So let's just do it step by step. So the first interesting thing.
Okay. I'm going to try and see how my train of thought would go if I solve this. Even though this is not a practice problem, but let's just practice. So, for the solution, I guess I would personally just, so this is like per, he said that this is how much you would use, but then this is not gram. I mean, this is not milligram. So let's just, do I just add a 0? Is it just 9 milligrams? And then I need to make this kilo, and I think it's 2.2 pounds is a kilo. So maybe 5 times 2, 22. And then I would just times this by this. And then times this again.
And this is just something that you might need to know, or you might have written down on paper, or you might have a calculator that does this. It's just how to convert kilograms to pounds. And it's good to know in general if you're converting between the metric and the English systems.
I do sometimes.
So 1 kilogram is approximately equal to 2.2 pounds. Not exactly, but that's a
Yeah, I've needed to know my weight in pounds because sometimes it's necessary.
pretty good approximation. And 1 pound, if you just take 1 over that, 1 pound is approximately equal to 0.45, 0.45 kilograms.
Actually, I did not know this other way around. I just know this way around.
So we'll just put this in a box. This is the only kind of outside conversion information we'll need to do this problem. Everything else, we'll just need a calculator unless we just want to spend a lot of time doing some arithmetic. So the first thing, let's figure out our dosage in terms of per kilogram. This is per pound, and we really don't need to know every 12 hours because they're saying how many milliliters of solution do we do per dose? A dose is every 12 hours. So we just really, the every 12 hours is kind of extra information. So we want to figure out this 5 milligrams per pound. How do we convert that to how many milligrams per kilogram? So let's do 5.
I would just say times 2.2.
I'll write it down here in magenta. 5 milligrams per pound. And then we want to convert this to per.
Oh, I'm like, why does he continuously write 1B? No, it's LB. Okay.
Kilogram. So we could multiply this times the number of pounds per kilogram times, I'll do it in yellow, times this information right up here, times 2.2 pounds per kilogram. And if you ever get confused, gee, how did Sal know to multiply by 2.2 instead of divide?
Because we want the pound to go away, and it's down here, so we get something up here so that it goes away, right?
By 2.2, which is the same thing as multiplying by 0.5, you can pay very close attention to the units. And notice I wrote 2.2 pounds per kilogram, 2.2 pounds per 1 kilogram. And you'll know this will work out because you have a pound in the numerator and you have a pound in the denominator. That's called dimensional analysis. But it's a very, if you ever get confused with these things, and I think once you do enough practice, you'll find that you won't have to pay too much attention to this. But at first, when you're getting started, just to make sure you're not, multiplying or dividing by the wrong thing, just make sure the dimensions cancel out. Pounds in the numerator, pounds in the denominator. So let's do that. Pounds in the numerator, pounds in the denominator cancel out. and you multiply 5 times 2.2. 5 times
Is it like
2.2.
13?
This is equal to, see, 5 times 2 is 10. 5 times 0.2 is 1. So this is equal
11.
to 11.
Okay.
And then in our numerator, we have milligrams. 11 milligrams per kilogram. So we've just converted our dosage information to a pure metric system. I mean, it was actually a mix between the metric and the English system before. Now let's see what we can do. Well, let's see if we can get it in terms of how many milliliters we have to deliver per pound. So once again, we want this. Well, actually, let's go to grams first, because we have milligrams here. We have grams
So we would get 1.1?
up here. So let's see if we can convert this thing to grams. So just like we did.
The way he talked, I don't know why there was a p in the mic. Did I just do that myself? And that was really loud and it scared me.
Before, we want a milligrams in the denominator. I'll do it in orange. We want a milligrams in the denominator, and we want a gram in the numerator. And why did I say that? Because I want this and this to cancel out, and I want a grams in the numerator. So how many grams are there per milligram? And you can just think
10?
it through. There's 1 gram.
I have no idea.
Per 1,000.
I don't know, by the way. It's not 10, it's 1,000. Got it.
Milligrams, or 1,000 milligrams per gram. And you just multiply it out. So the milligrams cancels with the milligrams, and then we get this is equal to 11 over 1,000 grams per kilogram. Grams per kilogram. So now we have everything in terms of grams, but we want it in terms of milliliters. The question is, how many milliliters of solution per dose? So let me go down here on this line right here. So we had what we had. This.
So we get this, and if we want the milliliter to remain, I would like divide this by this. And I guess he's keeping the ratio thingy so that when we do the division, the numbers are easier to calculate.
This result, we have 11 over 1,000. I won't do the division just yet. Grams of drug X per kilogram. This is really just we've just rewritten this dosage information in different units. And let's see how much solution we need per kilogram. So what I want to cancel out the grams here and have a milliliters there. So to cancel out that grams, I'm going to have a gram
division
in the denominator and a milliliter in the numerator. And a milliliter in the numerator. So in our solution, how many?
And this is 9 out of 10. It would be 10 over 9 then?
Grams are there per milliliter? Well, they told us there's 0.9 grams per milliliter. Or for every 1 milliliter, there are 0.9 grams. Notice.
Okay, I guess I wouldn't have written it that way. Thank you for the milli to non-milli. Because like when it comes to meters, between meters and centimeter, it's 100, and then centimeter to milliliter is 10. So that's where I got that issue. But between meter and millimeter, it is 1,000. So yeah, that's where I got it wrong.
So I just took the inverse of that because we want a milliliter in the numerator, grams in the denominator, so that these two cancel out. And let's do this multiplication now. So our grams cancel out. We have milliliters per kilogram. Milliliters per kilogram. And then we multiply it out. 11 over 1,000 times 1 over 0.9. So I'll just keep
millimeter or milli whatever. I see. Yeah, exactly.
Let me just write it like this.
Same as kilo, like kilo whatever. You just add 1,000.
This is going to be 11 over 1,000 times 0.9. Times 0.9 milliliters of our solution per kilogram. So we've gotten this far. So this is per kilogram of patient body weight. And then finally, they tell us how many.
Finally, we get the dose. So we divide the patient's weight by it, right?
Kilograms our patient weighs. So let's do that last multiplication.
It's multiplication?
Get our calculator out and do it.
Oh, how much the person should have. So per weight This is per kilo, and we have 72 kilos. Okay.
All at once. So let's multiply this times. We want to know how many milliliters per patient. We want the kilograms to cancel out, so we want kilograms per patient. And we're talking about this particular patient. Not every patient is going to be the same number of kilograms. But if we do this, kilograms will cancel out. We'll have milliliters per patient, milliliters of solution per patient, which is exactly what we want. We want milliliters of solution per dose per patient, but everything we've assumed so far has been per dose. So how many kilograms does a patient weigh? Well, there's 72.7 kilograms per patient. That's how much the patient weighs. So we just do this final multiplication, and we'll be done. So our answer, and these two things are going to cancel out. So our final answer is going to be 11 times 72.7 divided by 100 times, actually 100 times 0.9 is pretty easy to figure out. That's 900. Divided by 900 milliliters per patient. Or you could just say milliliters per dose, however you want to say it, per dose per patient. So let's get our calculator out and do this. So we have 11 times 72.7 is equal to 799 divided by 900 is equal to 0.88. Well, we could round up 0.889. Hopefully the doctor won't mind. So that is equal to, this is equal to a nice vibrant color.
I would give the doctor the final answer of 8885, just to be sure.
0.889 milliliters of solution per dose. So this is what we're going to give every 12 hours. If they ask how many total milliliters over the course of 2 days, we would have to say, oh, there's 48 hours. We'd multiply it by 4. But that 12 hours was extra information in this problem. But anyway, hopefully this is hopeful. This is useful, and it'll help ensure that any nurses serving me in the future are giving me my proper dosage. And hopefully the doctor even got the right dosage to begin with, because otherwise it's all for naught. Anyway.
What I am curious about is that aren't there sort of like a ready-made equations for them? I hope that there are, because I don't want my patients and doctors to like I would worry if my calculation is right, and I don't want them to worry if their calculation is right. Why is it important to be able to convert rates? Because it's fun. I actually find it fun. How do we go about choosing appropriate quantities? I feel like we sort of answered these questions. Like I really don't want to read the frequently asked questions because I feel okay with it. I mean, yes, it does make my brain hurt. I get that. But it is interesting. Oh, that's so cute. Problems are the questions that trip me up. I do not understand where to put which unit. Same. Well, I guess not to cancel. That one is not as difficult, but still, my brain will hurt either way. How are math and creativity changing the world? Ooh, a NASA research scientist. Okay, let's listen to them.
The maths underpins everything in our universe, so it impacts every corner of our society. But over the past decade in particular, the advances in computer technology and the introduction of machine learning and artificial intelligence has been massive. And we're only learning more and more and building better and better systems. And maths underpins all of that, and it's fundamental to all of those systems. And in fact, computer science is inherently linear algebra, so it's really foundational to those scientific advances.
One relatively recent example that really inspired me was the first real photo that scientists were able to capture of a black hole. Those mysterious remnants of giant stars that lurk all over the universe. And it is the way the scientists used creativity and math to solve the problem that was so fascinating. You see, these black holes are so distant that there's no single telescope that is large enough to be able to actually see them. And the scientists came up with this clever idea, creating a network of small telescopes distributed all across the globe that were synchronized to capture and focus the same object at the same time, creating a giant virtual telescope. Now, the aperture of this giant virtual telescope is nearly the same size as the diameter of the Earth. And with that in place, the scientists and engineers were able to capture all the bits and pieces of data and put it all together into the first image of a black hole that is 53 million light years, which is 318 quintillion miles away. Now, that's an impressive use of creativity and math.
Nice. I like the fact that she said computer science is basically math. Yes, it's just basically abstractions of math. All set for the units test. Yes. Okay, 10 problems. Will I be able to do this in the next hour? They took a picture of a black hole. They did. Yeah. When was that though? Was it 2 years ago? 3 years ago? I mean, it's not a picture like tick tick. It's not like that picture taking. It's just turning data into visuals. So yeah. They said that they had to transfer. Saw nothing and said, "Yep, it must have worked exactly." Exactly. I think they had to transfer the information by trucks because it was too much. That's what I heard. Or maybe it was because of secrecy. I'm not sure. But I did watch a few. Like, I watched one of the lectures that one of the people involved gave. It was not a selfie, right? Yeah. Would have been fun. I guess every picture that the James Webb Telescope takes is sort of a selfie because like when you see the images taken by the James Webb Telescope, you can tell because it has 8. Each star has 8 points because that's the number of mirrors of James Webb versus what's the one that Hubble versus Hubble. Okay, I need to show you this because I find it really interesting. So let's do a Hubble picture. I mean, obviously, obviously Hank Green has a video about this, so I'm not like saying something that has not been said. I know about that because of Hank Green's video, but James Webb Telescope photos. So the photo that wait, is 5? Why did I think it was 8? Is still it's useful information. So if we look at let's see if I can so it's 1 2 3 4 5 6 7 8, or is it not? Like how many mirrors does James Webb have? A lot. I don't know. Okay, I guess I got it wrong. But like the difference between pictures taken by Hubble and James Webb is that you can see it from the shape of the star, basically. Okay, so that here we can see this one has 4. I guess. See, I don't even know how to relay the information, but that is something that I am relaying. 1 2 3 4 5 6. This one is 6 and this one is 4. I guess that's how you can tell one is Hubble, one is James Webb. And now I am going back to math because that's, hey, gardens. Can you tell how much our trees are growing? Is this about that? Raya is applying. Yep, we're back to the mulch and the garden. She applies it at the rate of this much for mulch every meter square of garden. Meter cube. 3 is cube, right? And this is square. So, we have centimeter. That's the problem. So I just turn centimeter into meter, and I think I need to do like 100 times 100 times 100. So it's just a million basically. So just add 3 more, and this is per meter already, so just add a bunch of zeros. That's what I'm gonna do. No, not add, it's divide, because we're making something small into something bigger. So 250 123 divided by 123 123. So this goes away and that goes away. So it's 25 divided by 10, which is 2.5. 2.5 is my final answer, and I hope it's correct. 그래? Then 2.5 seems reasonable. Do I make it 25 divided by 10? Or 2.5 divided by 1? No, the answer is just 2.5 though. Please accept that. You did not. Do you want me to say divided by 1? Or do you want me to say 25 divided by 10? Or did I even get that part wrong? I even got that part wrong. Okay. Yeah. Give me another hint. All right. Oh, it's 0.25. All right. I did get it wrong then. Well, question wrong. Thank you. Let's do another one. The formula for calculating wage, P divided by T, where T is time duration for the amount of money. Yeah, that makes sense. Astrid is looking for a job. Wait, Astrid, didn't Astrid have apple orchard? What happened? Why does she want to work at a call center? Call center A offers $15 per hour and B offers 25 cents per minute. I just need to convert those two. Fine. I don't even know the cent to dollar ratio. 25 times how much to get to $1? And here's the thing, it's like 25 per 1 minute, and this is cent, and we need dollar per hour. So even then I need to do something with 60. Like it's twice, because the other one is per hour. Is dollar to cent to dollar is so it's just 10. 100 cent. Ew, okay, it's 100. It's 100. Okay, so cent to dollar is cent per minute. I guess I don't need to turn the cent into dollar. I just need to times. Okay. Here's how we're doing. We have 25 cent per minute, and if we do $100 well, no, I wanted to do the minute first. Hold up, let's still do the minute first, and then we'll divide by 100, and then we'll get the... So 25 cent per minute, and if we want to say we have 60 minutes per hour, we would get 25 times 60. I have no idea. let me get a calculator. 25 times 60 is 1500. So we would get 1500 cent per hour. Now we say $1 is 100 cent. So the cent goes away. These 2 zeros go away. We get $15 per hour. They're equal. Gosh darn it, they're equal. That was very difficult. Okay. Analia. Wait, didn't we do that already? We absolutely did that already. The numbers are exactly the same. I should just look at my yesterday's video. So, higher average SAT relative to the resources invested. And what are the resources? 2 ways of defining this. SAT, higher average resources. So budget is resources. Teachers are resources, in my opinion. And if we look at SATs per budget and SATs per student, let's see which school does better. And we're talking about SAT average. So SAT average per budget. I mean, school B looks better in that front to me. Let's just get a calculator and do it. I don't have the patience to math myself. So let's do budget, SAT average per budget, which is do you say budget divided by SAT average, or do you say SAT average? Because like for the teacher, I would just say 1200 divided by 190, and we have 6.3 for school A. School A is 6.3, and 152. I feel like school A was better always. Divided by 380. That is very low, very, very low. And if we do it for the budget, how much we're spending per SAT average, for that one we would get like, is it $10? 1 0 1 2 3. But this is per student, but it's okay. I think that's okay. 1050. We get like $9.5. And the other one, school A sounds better to me. 1 1 2, and then divided by 900. Wait, no, not 900. The number is 1200. 1200. Ooh, it's cheaper, which is a good thing, right? Is that a good thing? I mean, the number is lower for money, but that's good for me. Yeah. B has the higher average to resources invested. No, A has the higher average. Good. Thank God I got that right. Oh, hi, Go. It was 20 months. I remember that one. Please be correct. Okay, I remember. Which one is that? Which school is better? Higher academic achievement. I feel like A was better either way, but I remember academic achievement. SAT divided by budget, graduation rate by student, that's academic achievement, number of sports, and graduation rate. Yeah. Oh my god, that was wrong. No, I made a stupid mistake. Let's try again. But like, relative to budget per student. But those two are correct. Wait, is A not better? Oh, it was opposing results that I remember, actually. Oh, no, I made 2 mistakes now. All right, this one I'm obviously gonna try and solve. A pitcher's arm rotates at a speed of 7 degrees per millisecond. I'm guessing we're talking about baseball. I don't like how American this question is. Just talk about football, for God's sake. And yes, I do mean soccer. At what speed does the pitcher's arm rotate in millisecond to second? That's 1,000. We something 1,000. Hold up, we want to convert millisecond to second. Second is here, so ms anında. Wait, not you, obviously. All right, let me just write this down. We have 7 degree per second. Okay. Yes, internet's still good. Good. And we have 1,000 milliseconds in a second. This is 1,000 ms in an s, but we want it rotated, so it would be 1 second per. Wait, no. Oh my god, this is millisecond already, so this part needs to be millisecond again. Let me just clean the board. Cleaning the board. There we go. So 1,000 millisecond per second means just times. Does that make sense? The more it rotates more in a second than it does in a millisecond. Yes, that does make sense. So my answer is 7,000. But that's just so much. That's just so much. Right? I'm scared. And it's correct. I know nothing about that. Okay. The formula for the size of a file that was downloaded over time, T, and an average rate, R, is rate times time. Sienna downloaded a file at the rate of 800 kilobytes per second, about 110 seconds. We need it in megabytes. Difference between kilobyte and megabyte is 100? 1,000? It's 1,000? I have no idea. I have forgotten all of my bytes. Kilobyte to megabyte. Yes, it is 1,000. Difference. So 1,000 kilobytes is 1 megabyte, basically. So that is like outsider information. 1 megabyte is 1 kilobyte. 1,000, for God's sake. 1,000, 1, 2, 3 kilobyte. So that's outsider information. Well, yes, 1,000. 1,024 is like the most correct one, but here we don't, like, here it's not as relevant. But I do appreciate that. 1024 is correct. So what would we do? First, we would need to turn new. We would just do this. C is my final answer. 아닌데? No. Hold up. Kilobytes is 800 kilobytes, which means we want to make something small bigger, which means divided by the 1,000, which is 0.8 megabyte. Yes. So answer D is correct. Why do I always make that mistake of like No, we should multiply. Wait, no, we should divide. I always make this mistake. Hi Astrid. Ships. Was it 7? Nope, it was 5. Answer was 5. Darn it. Why do I do that? Assuming what number of ships can be built. So they changed the question. It was tons. The final one was tons. The last one. And yes, I am the type of student who sometimes doesn't even read the question. Alright. 40 tons. Wait. How many number of ships can we build? 421. Wait. Am I remembering the apple orchard number? Because, the difference between these two was 7, and we, 7 times 40, I remember that number as well, which was 280, and then I was like we needed to divide it by something. Your calculation when you have it. How is your calculation when you have a timer ticking? Like if I was on a timer, I would probably even have more things wrong because there is no timer and I'm still trying to be hurried to do things in a hurry. But like, hold up. Is that the tons? Okay, we can do this. 40 tons of wood for 300 sailors. So we need number of ships. What is the number of ships Astrid can build? Isn't it just 7? Because like we need 7 ships? Or is it we have 100 days? So it's not about the sailors. Like, take the sailor information out. We have 100 days worth of 40 tons of wood, meaning in total we would get it's 400. We have 400 because 4 tons of wood per day for 100 days we would get that much, and divided by 40 we would just have 10 ships. We can create 10 ships. 10 ships? Yeah, cool, thanks. Charlotte is running at a rate of 9 kilometers per hour. Awesome. How much is it in meter per second? Well, Charlotte, kilometer to meter is 1,000 at the top. Meter to second is 3600. And there's the 9 here. So that's what we're doing. I would take those 2 away. We would get 90 over 36 is my estimation. And if we do 90 divided by 36 is 2.5 meters per second. Does that make sense? She can run 2.5 meters in a second. Oh wow, that was correct. Cool, good job, Charlotte. How much pay? 84.6, 82.6. Anyone remembers this number? I don't want to calculate. Oh my god, can I go back and get that Trevor's family number? Please. I don't want to calculate. I think it was 82.6. And I swear to God. Nope, not that one. Servings. Where did I get Trevor's family number? Dollars per hour. No, not the fleet. There. It was. I'm looking at my. It was. How many? Oh, I lost the question. I got the answer, but I lost the question. But it was like, okay, I see the number up here. It was, let's get the calculator. 72 times 0.2 times 6. I think that was the number I was supposed to get. So 72 times 0.2 times 6. 86.4. Okay. 86.4 is dollars per minute. Oh no. And I got it wrong again. Okay. Because per minute, not for the whole month. They change the question each time and I get it wrong each time. It's so much fun. This is for the whole month, by the way, if anyone's curious. But if we want it per minute, this is for the whole month. How many minutes are in a month? That is weird. How many minutes are in a month? Can I do that? Minutes in a month. 43,800. Divide that by 43800. No way this is the answer. No way. Anyway, I'm just gonna copy and paste this. Why am I being so lazy today? Uh-oh. I lost the number. Did I paste? Yeah, I lost the number. What the hell? Oh, it depends on the number of days in a month. Even that. Per hour, per day, per month. We could do that. But even the number of days per month, though. Hold up, let me try to read the question. Let's be civil for a bit. We have 6 people. 3 bathrooms, not relevant. Average. Each person showers an average of 480 minutes. So that's the number of minutes. And I'm guessing that's for the whole month. Okay, that's good. We have the number of minutes shower has been used for a month. And so it's not per person. Now the calculation is now because we have the dollars per liter. So average of this, is it just 72 times 0.2 and that's it? Oh, no, not that. Because is that 14.4? No, we already have the number actually. So let's not, yeah. Average of 72 liters of shower water for the month. And this is how many minutes? Hi. Oh, first time chatter. Hello. Quag or Q or G. We're struggling out here. Struggling very much with math. Because like I have the number of shower water for the whole month and for one person. we need it per minute. Do I just divide this number by 480? Divide by, not plus, divide by 480. And that's money per minute, which is 0.03. That sort of makes sense. It shouldn't be so much money. Here's me checking. Okay. Cool. Wow. So my appropriate quantity for modeling remained at attempted. And one level went up, which is formulas and units. It went to mastery. So if I go back to my algebra, we have one at attempted, one at mastery, two at good. Good for you. I have like half an hour, and I'm obviously not going to start a new unit, which I love. It's linear algebra. Wait, linear equations. Yes, and graphs. I love that. But it breaks my heart. NT? What would NT be? Hello, hi, good morning, Momo. So it breaks my heart to have this be at attempted, not even familiar, just attempted. So I'm just gonna try and get this one up. It's only 4 questions. Nice try. Thanks. Charlotte. See, like my brain doesn't want to compute this because I've already seen these numbers. And I'm like, I should know. And that's just not good. User engagement per writer. I remember solving all of these. Likes per writer, comments per writer. So that's outsider user engagement. And which website is doing better? Likes per writer, obviously website A. Comments per writer, obviously website A. So that one is easy to solve. Okay, wow, I honestly didn't know what NT stood for. Let's go. Question B. See, I feel like I've already solved all of these. Achievement budget per student. SAT average per budget per student, graduation per budget per student, and the answer is opposing. I have them all memorized already. Okay. What else? Still websites. Large amount of content per writer. Content being, so the number of words actually, this one is doing better. For post, I'll have to do them. I'll have to try to calculate. So number of posts and number of average number of words. And here's the thing. We have average number of words, which has large number. I feel like it's could be website 8, but it's not very obvious. So let's just calculate both of them. So number of words with writers, for that this would be divided by, though, not times. So this one we divide by 5, this one we divide by 11. For you we would get 2 and 0, 20. Same data. They should change one word in the question, but then they would get someone like me who assumes it's the same question and then get the answer fully wrong, just like how I did. 17, 0 divided by 11 is 15.4. This one here is 15.4. So for here, the number of words, website 8 is doing better, but for number of posts, divided by 5, divided by 11, what is 200 divided by 11? 200 divided by 11 is 18.1, and 110 divided by 5 is 110 divided by 5 is 22. So again, website A is doing a better job. Oh, well, yeah, okay. The other one was opposing answers, but here, why though? Where did I get it wrong? I want number of words per writer, number of posts per writer. I feel like those two are correct. And dividing those numbers, I do believe website 8 is doing a better job. Why am I wrong? $22 and 18, 15 and lower than 18 for sure. Where am I wrong? Which website produces larger amount of content per a single writer? So per writer should be correct. Average number of words per writer. Where am I getting this wrong? A is doing better. I'm gonna just look at steps. Understanding is that it isn't a single way amount of content. Number of posts can be a good measure. Number of words is a good measure. Number of characters, good measure. Amount of content per single writer. So yes, I feel like this part is correct, but the other part, so yeah, we got that right. And then for the other hint, 22, 18. See, I did the same error like last time. Number of words per writer. I should have, I literally made the same mistake. I remember that 30/90. Words per writer. We have words per post, so you say words times post, then writer. And then in that sense, B does better. So is it again opposing answers? Because in the first one, A is better, but in the second one, B is better. So it is opposing answers. And yes, I did get this wrong. Because this is words per post. So you have to say words, multiply by posts, divide by writers, and then. Cool. Same mistake. Good job, me. Which school has a lower SAT range relative to resources invested? Lower SAT range is a measure of inequality, which we need to minimize as much as possible. Lower SAT range divided. What is the SAT range? Min-max 900. Per number of students, per teacher per student, per budget per student. By how would I calculate that? Which school has the lower SAT range relative to resources invested per student? So budget and teacher are resources. Okay. So SAT range divided by teacher, SAT range divided by budget. And since SAT range is bigger, so lower is better, that's one thing. Since the SAT range is bigger in school A, both times I feel like school A would lose, but let's actually try and do it. So school A and B for this question, divided by teacher per student. Teacher per student? Oh God. So I need to calculate teacher per student, budget per student, and then get that SAT range. So teacher per student is, how many teachers per student? I guess I would do, is it like teacher per student would be like 190 divided by 3,000 on that side, and 380 divided by 4,000 on that side. That's number of teachers per student. And then divide everything by 900 here and divide everything by 700 here. So that's for question B. For question C, budget per student, budget here is 10,500. Student is 3,000. And here it's just 10K, 4,000, and then all of it same, 900 and 700. God, this looks ugly to look at, but it's okay. Let me just divide those two questions first. Okay, let's try to solve it by eyes first, because like here, this goes away, we have 19 divided by 300, we have 38 divided by 400. They will ask the same question tomorrow to check you will make the same mistake for the third time or not. I mean, I'm going to go to the next unit, hopefully, so I hope it's not the same question again. And then here, 2 zeros with those 2 zeros, 3 zeros with those 3 zeros. This is 10 divided by 4, which is 2.5. Anyway, I'm just gonna get a calculator and just do everything while we talk. Calculator, where's my calculator? I have lost my calculator. There it is, found it. And I'm going to be using it on the second screen, because if I bring it to the first screen, I won't be able to use it. So, we have 19 divided by 300, and that would give us 0.063. We need to divide 900 by 0.063. So this number is that right? So for here, I got, and let's write it in a different number color, 14285, and then let's see what we get on the other side. 38 divided by 400 is 0.095. That's the number of teachers per student, by the way. So 0.095, 700 divided by 0.095 is, on that side we get 7368, and this one is bigger. So for that, just because this one is bigger, it means that's a bad thing. So like, this is bad, this is good, because the lower the better, question mark? I don't know. Because that is SAT range by teacher per student. So that's A is bad for B. Let's try this one. We have, I get when the kids wrote "my brain hurts," because right now my brain is like running around like that SpongeBob meme. 105 divided by 30, 105 divided by 30 is 3.5. Okay, and then we have 900 divided by that 3.5, and this number is 257.14. And for the other one, we have 10 divided by 4, which is, yes, 2.5. Cool. 700 divided by 2.5. 5 is 280. 280. Now we see a difference. Now this is the bigger number, which we're guessing is wrong. SAT range divided by budget per student. So, final answer is that they're opposing numbers. Yes, opposing results. Please be correct. It is not correct. Fun. Okay. SAT range relative to resources. Yes, we got that correct. And, wow, my numbers are very different. Lower SAT range. So, these two are actually correct-ish. A is bigger, but here, B is bigger. Which, isn't that opposing? Or, it doesn't matter. Because we said anything that's... Both has a lower. B is lower? 0.00, I guess 0.07 is... So B is better? And did I get attempted again? Did I just get attempted again? Wait a second. Is Aaron correct that I need to take this unit? I did. Yep, I need to take it again. We're gonna speed through it. How much time do I have? I swear to God. Higher academic achievement relative to the number of teachers per student. Academic achievement, graduation rate. No. Teacher per student. Graduation rate and SAT average. Graduation rate and SAT average. I'm just gonna say A is doing better. Haha. I didn't solve it. Haha. Oh, I just feel so mean right now. Gains more new subscriber per amount of content. Subscriber per content. Post and words. I think this is a new question, actually. I don't remember solving this one because the number of subscribers is so high for B. And the content, words and posts. Like, it has to be website B. But hey, let's try and solve it. So, okay, where did my coloring thingy go? There it is. Subscriber per content, we have 20,000 divided by 200, and then number of words. Number of words is always this times this, and then we do the division. So let's just get the calculator and try to solve this. This is very frustrating. So number of words is the first thing I need to do. 1000 times 110 is number of words for website A, and then we can divide 900 divided by no, there's another zero. There is another zero. So here is almost like one subscriber per word. So this is 0.81. And that is for subscriber per word for this. For A. Let's get it for B, which is 170 times 200. And then we get 220, 1, 2, 3, that. Oh, that is a way lower subscriber average per. So for the first one, actually for the second one, B is worse. Let's try for the first one, which is posts, subscriber per post. And number of posts, I feel like website B would win on that front, but let's see. 20, 1, 2, 3, divided by 200, we would get 100 subscribers per post. And for that one, we have 9,000 divided by 110. 81. Yeah, opposing. Because now website A is doing better. Worse. This one was 100, so opposing results is my final answer. Ta-da! Question 3 out of 4. Which website generates profit per resource invested? Profit. Profit, resource invested, so expense and number of writers. I remember website B paying their writers better because expenses. Am I correct? Yeah. See, we have 5 writers. But like, I need to take a break. My brain is not working. Wow. Okay. Yeah. I'm just gonna take a hydration break, like for 2 seconds. Drink some water. Oh wow, I just realized that I have not been sharing the screen. I'm sorry. Why though? Oh. When I got the calculator out, that's when I did the mistake. Whoops. Okay, it's alright. Today is a day of struggles and mistakes. And those days happen a lot. Alright, so which website more money? Nice. Profit. Good. So profit by expense. Well, profit already includes expense. So it's number of writers. And then expense, number of writers. Profit per writer. Let's get a calculator. Profit is not 2 actually. It is 1 0 0 0 and another 0 divided by 5 for A because we have 5 writers. That is 2,000, and the other one is 28000 divided by 11. That is more. This is more. This is 500 more. So B is doing better for the first one, and for the expenses, I think the 47 3 zeros divided by 11 is 42, and then the 21 2 3 divided by 5 is 40, meaning expenses by writers, B is more expensive. So B is more expensive, but B generates more money. So I feel like it's opposing results, but I'm wrong. So let's just say B is doing better. I'm wrong. Let's just say A is doing better. I'm wrong. Did I get it wrong? Is B wrong? I think B is doing better though. Oh god. No way, A is doing better. Yes, A is not doing better. Am I choosing wrong things? Is it profit? It's profit. Alright, I got that obviously wrong. My brain is absolutely fried. Athletic achievement. Medals won. And medals won per SAT, because we're saying athletic achievement relative to SAT. I'm guessing those two, and in both cases SAT average is higher, medals won is higher. It has to be A. I swear I don't have the energy to solve this. Well, I don't know. I don't have the energy. And I just got attempted. Wait, are you not letting me try again? Am I so bad that you don't even want me to try again? Yeah, I will continuously practice until I get this wrong. I memorize every question. Academic achievement per student per budget per student per budget per student. How did we do in the academic achievement? I don't remember. I'm just gonna say opposing results. Oh, this is getting not good. I'm here for 10 more minutes, people, and I'm out of here, even if this remains that attempted. Academic achievement relative to the number of teachers per student. Teachers per student. School A is really bad at this one for teachers per student. So I feel like school B is always good. No. Well, then opposing. Well, then A. What else? Revenue per amount of content. Absolutely opposing results, right? No? I remember the 30/90. Revenue. Maybe. No, I doubt it. The questions are changing, by the way. Revenue per content. Revenue per content. Revenue per content. So revenue per post, let me try and calculate this one. I see post 75000 divided by 200, 375 for B, 375 for B, and 30000 divided by 110 is less. So B is winning in the first front, but I'm not gonna submit yet because it's the number of words. And for the number of words, first of all, we need to get the number of words. 170 times 200, and then divide revenue by that, which again I'm guessing B has to be better. Maybe 70000 divided by answer. Where's ants? $2.2 per word for website B, and for website A it's 110 and then 2 more zeros, and then the revenue is 3. Oh yeah, why go there? I told you to go to the first part. One more. 30123 divided by 2.7. Ooh, okay, opposing results. Nice, I solved this one myself. And user engagement per single dollar expense. Who gives a... Oh my god, I am bored. There's a reason I don't like this one. I have 2 correct. If I don't get this one correct, I'm gonna get attempted again. ChatGPT is really good with those ones, honestly. But I am not ChatGPT. I'm just little old CL struggling. User engagement per single dollar. Oh god, I hate this. Okay, number of likes, no. User engagement per money. So comment per expense, like per expense. That's it. Is that how we calculate it? Let's get our calculator back. Average. Total. I hate this. So for average, I just need to multiply it by number of posts. So what, can I get myself a pen and paper? Because I cannot keep all of those numbers in my brain. Or maybe just open a note app. I'm gonna open a notes app. Give me a second. Where is the notes app? There it is. Notes app. Notes app. An application that contains notes. Notes app. Why are you being mean to me, Notes app? Okay, so I have my Notes app open so that I don't need to save every number in my brain. So what I need is total number of comments and total number of likes. Let's get comments and likes, right? I hate you, Notes app. I really do hate you. Thank you. All right. Oh my god, I hate it even more. Comments. I am getting delirious right now. Total comments. 500 times what's that number? 110. Our total comments is, that's comments, right? Nice. 5 zeros. So that's our total comments. And to get divided by expense, divided by expense is, what is expense again? 20123, and now it's 2.5. So for the comments, website A is 2.75. Now I need to do the same for website B. I'm just thinking every life choice that led me here. 450 times 200. My hand hurts. 450 times 200. And then divide that by expense here is 47123. And that's 1.91 for website B. 1.91 for website B. So now we have the comment one. Let's do the like one. For the like one, we need number of posts is 110. Number of likes per post is 3512. And then divide that by expense. And for here, expense is 20,000. And that's 19.25 for the likes. Is that the number of money? 19.25 for A. For A. And for B, or is that like 19 likes per dollar spent? For B, their like average is the same. 3500 times 200, because that's the number of posts. Divide by, do they get in lower? 47123. 14.89. So yes, they do have a lower like ratio, but not by much. Well, by much, I suppose. 0.89. And that are my numbers. Thank God. So for the likes, A is doing better. For the comments, A is still doing better. So in both, A is spending less money. And now we get the bonus question. Of course. Which more profit per resource invested? Profit per resource. Writer is resource. Profit by expense. I feel like, is this a feel-based question, or is this a fact-based question? Because I remember profit per writer, website B is doing better. No, website A has to do better, because no, website B is doing better. And profit per expense, visually, website B is doing better in both cases. I could be wrong, and let just this remain at... Okay. Shut up. Shut it. I'm not happy. Do not celebrate this. Ugh. Yay, everything purple. Good, me. Alhamdulillah, we did it. And I did just answer one of them with vibes. Actual vibes. Because sometimes you can see numbers and tell, you know? And I'm gonna go now. 2 variable linear question, slope, horizontal and vertical lines, x and y intercepts. Yay! This sounds like fun. I mean, we'll see. I could just get as bored as I got like now. So everything is purple, yay me. And I saw this go by 1% after I got this from attempted to proficient. So my course mastery is now at 12% here. That's it. That's the only thing that went up. And I am cool with that. How's our profile doing? Where's my profile? Learner home. Is my profile also struggling? Oh, hey. Units is 85%. And I am like absolutely going to go to the next part. So linear algebra, just algebra foundations, 100 equations and inequalities, 98%. And we're in units, 85%. I'm cool with that. I don't mind that. I think if, I don't know, but I'm just saying, if I got even maybe 70, I would be fine with that, because that would mean, I don't know fully, but I'm assuming it would mean, if I go to resume, where are you going to take me? Well, I want to go here. I have 1 mastery, and that's what keeping my my score high. But if everything was just proficient, I feel like I would get something like 75, which I would not mind. I am happy with that. I don't care. But I do want everything to be purple at least. That is my goal. Okay, and that's it for today. How much did we struggle? Like so much. So much. Today was a struggle. But hey, it happens. That's the joy of learning. And public learning, I suppose. I call my style of content slow learning. So yes, that's all of the struggle, that is me, slow learning. For math, I do want to continue the slow learning and not try to get a language model involved. But if I'm coding something, I would for sure use a language model. So I'm not that trying to be, I don't know, pure with my learning. But for me, what do I want to use brain power versus what do I want to be efficient about? And for work related things, most of the time it's a mix of both brain power and efficiency. It's not always let me learn this as slowly as I can afford to. You can't always afford to learn things slowly. But I guess that's the joy of me streaming myself learning math step by step. Today was difficult, but we powered through, and now everything is purple, and we're done with the units part. So see you next time, I suppose, right? For the equations, linear equations, which I truly hope that I will do better. If not, it's okay. That's again the joy of the slow learning that we're doing here. So sorry for I'm not sorry that this is how I learn. I'm just sorry that I think this is not entertaining content. But if you're here, then you're here to struggle with me. Yeah, thank you for being here. Thank you for supporting me through this. And I hope that I we are learning together. I hope it's not just me struggling. I hope at one point you are learning at least one thing, even if it was about the James Webb Telescope and the Hubble Telescope, whatever it is. Yeah. So I am going to go to the end screen. I appreciate you for being here. I hope you have a lovely rest of your day, and see you next time, inshallah. Bye.